Let's draw the Lewis structure of CO, recognized as carbon monoxide. To represent the Lewis structure of CO, follow these steps. Begin with a rough sketch. Depict the chemical bond between the carbon and oxygen atoms. Identify and indicate any lone pairs on the atoms. Verify that the octets of both the carbon and oxygen atoms are complete. Finish by calculating formal charges, aiming for a stable Lewis structure with the least formal charges possible. Before we draw the rough sketch, let's start by calculating the total number of valence electrons and then identify the central atom. The total valence electrons in CO can be calculated by summing the valence electrons of each atom. Carbon, a member of group 14, contributes 4 valence electrons, while oxygen, a group 16 element, possesses 6 valence electrons. With 1 carbon and 1 oxygen atom in CO, the total valence electrons calculation is 4 for carbon plus 6 for oxygen, resulting in a total of 10 valence electrons for CO. When selecting the central atom for CO, give preference to positioning the element with the lower electronegativity at the center. Considering the electronegativity values of carbon, which is 2.55, and oxygen, which is 3.44, opt for carbon due to its lower value. Consequently, for the initial sketch of CO, position carbon at the center and place oxygen next to it. 2 electrons represent a single chemical bond. Therefore, we will position 2 electrons between the carbon and oxygen atoms to indicate a chemical bond between them. In this way, out of the total 10 valence electrons, 2 are used, leaving us with only 8 electrons. Lone pairs consist of electron pairs not utilized in chemical bonding. Remember, each pair comprises 2 electrons. With 8 electrons remaining, mark 4 electron pairs on the structure as lone pairs. It's important to note that both carbon and oxygen, being period 2 elements, cannot hold more than 8 electrons in their valence shells. Another key point to remember is to always start by marking lone pairs on outside atoms first and then on the central atom. In CO, the outside oxygen atom will receive 3 lone pairs, while the central atom, carbon, will get 1 lone pair, as we only have 4 lone pairs to mark on the structure. The octet is complete on the outside oxygen atom, but not on the central atom, carbon. Let's now focus on completing the octet for the central atom, carbon. Once again, note that carbon is a period 2 element and cannot hold more than 8 electrons in its valence shell. Carbon already possesses 4 valence electrons and requires 4 more to complete its octet. Therefore, we will convert 2 lone pairs from the oxygen atom and transfer them to the carbon atom to form a chemical bond. Now it is evident that the central carbon atom, as well as the outside oxygen atom, both form an octet. Thus, the octet rule is satisfied, and we can now proceed further to check the formal charge to determine the stability of the structure. This is the formula we can use to calculate formal charges for the CO Lewis structure. Formal charge equals valence electrons minus non-bonding electrons minus half times bonding electrons. Simply input the data and place the values in to obtain the formal charges for each specific atom. For carbon atom, valence electrons are 4, non-bonding electrons are 2, and bonding electrons are 6. So the formal charge will be equal to 4 minus 2 minus half times 6, which equals to -1. For oxygen atom, valence electrons are 6, non-bonding electrons are 2, and bonding electrons are 6. So the formal charge will be equal to 6 minus 2 minus half times 6, which equals to +1. The formal charges of both carbon and oxygen atoms are mentioned, and it is evident that the current structure has formal charges closer to 0. Therefore, this structure is the preferable, most stable Lewis structure of CO. To represent a pair of bonding valence electrons, we can simply draw one horizontal line. Since there are 3 pairs of electrons between the carbon and oxygen atoms, draw 3 horizontal lines between them, signifying that carbon is triple bonded with the oxygen atom. That's the Lewis structure for CO. If this breakdown helped you understand, show your support with a like, share this video, and subscribe to the channel.